All right, so last time we finished the list module, and I accidentally skipped this optional module because I just read these two, and then skipped down here. But let's finish the optional module. I'm going to boot up my terminal here and start from the top. Okay, so the optional module, we create our own data type called optional, parameterized by A here. And you construct an optional using this full constructor in the value or with empty. So main just defined in files. That's going to be okay. Going to load L is short for load. Course option. Okay. Optional. Okay, so we have our data type here, and I can construct one using full. So O is full one. Or I can say O is empty. I can check on O, it's an optional A, and it's empty. So one thing I've heard about optional, in this course it's called optional and the constructors are full and empty. But if we hop over here to I go to a regular GHCI and not this particular project, which is not including no implicit prelude here, is saying don't include the core library. So if I go into regular GHCI and there is this data type called maybe, which probably a lot of folks are familiar with. So if I look at the maybe type, it is maybe A and is constructed with nothing, or just A, which is very similar. I mean, it's identical to this basically. So I can say, maybe is just one, or it's nothing. And so one way I've heard maybe talked about or optional talked about is it's very much like a list. The list can either have elements in it or it can be empty. And so optional is it's like a list with a maximum length of 1. So it's either empty or it has its one element inside of it. So that's kind of a helpful intuition to have. So okay, let's go dive into the first exercise here. The map optional, we take a function from A to B and an optional A and we return an optional B. So I can start out here doing a type toll, reload. And so we have our optional A here and we have our function A to B. We can't run the function on optional A because it's not of type A, it's of type optional A. So what can we do? Well, we can deconstruct this optional. So I can say, instead of OA here, I can say pattern match optional A. No, not optional, full A. So, but if I do this, then now what happens when it's empty, right? So it might not be full, it might be empty. So, whoops. So I should probably match on empty first. So if it's empty, we need to return an optional B. But how do I make one? I don't have any. I don't have an. Well, I have an optional. It's the empty. The F, I can't do anything with. So I'll just return empty. It's kind of like map over an empty list. Well, given this function, but what do you do with it? You just return the empty list. So that's what I'm going to do. I'm going to pattern match on empty and return empty. If it's not empty, if there's a value in here, well, so let's go through a type tool just to show. So now this A here is of type A instead of optional A, and I have a function which takes an A. So if I apply F to A, this will give me a B, but I need to return an optional B. Well, I can construct an optional with this full keyword. Full. Do I need to wrap parens around this? My guess would be yes. Bump up the font a little bit. How's everyone doing, by the way? Is anyone out there in internet land? Full f of a. Couldn't match expected type. Yeah, so I think I need to wrap this f of a. So apply f to a first and then construct the optional. Reload. Cool. Seems to compile. Let's test out. Map optional. So if it's empty, if we try to add 1 to empty, then we just return the empty because there's nothing to add 1 to. Hello. Thank you for saying hello. I appreciate that. I'm also interested. What is your Haskell? What is your familiarity with Haskell? Are you an expert Haskell pro and come to impart your wisdom, or are you a fellow beginner or somewhere in between? I would be interested to know. So what happens if we try to map on a non-empty value, a full 8? Hey, we get a full 9. So we get our plus function, +1, and we get our full 8. We pattern match that, deconstruct it. So a is 8, and then we apply the function 8, which adds 1 to 9, and then we wrap it up in optional again. So now it's a full 9. Oops. Cool. So this is very much just like, I mean, it's the same thing, right, as doing +1 on a list with 8 in it, except I don't have map because, all right, let me see. I have to add source course list because we made our own list. I mean, we made our own map. We made our own list data type, and we implemented our own map. And I think, is it just called map or is it called map list? Map. Okay. So what was I trying to say? Oh yeah, map. Expected. Oh yeah. So the way I construct my custom list is with the constructor we defined, which is this cons method. So I have to cons 8 to nil, and that's how I construct one of my lists. So mapping +1 over this list is very similar to doing like full 8, except it's not called map, it's called map optional. And we get a full 9. So so that's what it's saying. Like you'll hear often that the maybe type or the optional type is kind of like a list with a max length of 1. How do I pronounce your name? PFMRF. Murph. Pmurf. I would say I'm somewhere in between beginner and expert. Awesome, me too. I've read through the Haskell book. By the Haskell book, do you mean Haskell programming from first principles, or do you mean some other book like Learn You Haskell? Because I'm interested in doing a book. I've gone through most of Learn You Haskell. I think maybe I could go back to that. Haskell programming from first principles. Okay, I've heard that's really great. I also think that FP complete. When I've like Googled around for Haskell resources, they come up a lot. They kind of remind me of I come from like a Ruby or like Rails background, and this company kind of reminds me of ThoughtBot, which is like they're like why can't I think of the word? And like an agency, so they like you hire them to build you a Rails app or whatever, and they have a blog about Rails. So this kind of reminds me of like a Haskell ThoughtBot, and they have you can hire them to help build you a Haskell app, and they're kind of one of the foremost people using Haskell in production to and industry. And I think I just wanted to point this resource out because it's been really helpful to me. Getting started guide. Yeah, here you go. And the reason I brought this up is they bring up, where is it? How to play. At some point they say you should read Haskell programming from first principles. Yeah, there we go. That's where it came from. So I kind of want to do this. EF Murph says Pete is fine. Oh, hi Pete. Nice to meet you. Thanks for joining the stream. I'm having a lot of fun doing this, and I hope it's useful to someone someday. So we've done map optional, and now I'm going to do bind optional. It's good, but it is very long. Yeah, it does seem like it. I've heard that it's very long. Bind optional. So that to the keen observer, you might notice that back in our exactly one module, which was one of the introductory modules, no exercises, just like something to try to learn the syntax. We have this run exactly one, map exactly one, bind exactly one, and this pattern will reoccur, and we'll see that, and we'll see why later. I'm also trying to go faster this time because I think the past two streams have been like 3 hours, and I don't think I should do that. I don't think it's good for me. So I want to be able to sustain my streaming efforts long term. So maybe I'll try to keep it like 2 hours or less. So no pressure to stay that long, anyone. But so bind optional. It takes a function A to optional B. This just go to list because there's one function similar to this. Oh, which one was it? Maybe I should just look A to list. Yeah, flat map. So it takes an A to list B, a list A, and it returns a list B. So that's looking very similar to this. A to optional B and optional A returns an optional B. So again, I know I'm gonna need this A value inside of the optional, just like I did with map. And I'm thinking I'm gonna have to pattern match, but why don't I just go ahead and start with the title because it's always helpful. So yeah, I have this optional A and I have this F which takes an A. So I pretty much have no choice yet but to unwrap this. I'm going to say if it's an empty A, or if it's an empty, don't need the prints, then I think I'm just going to have to return empty. If it's a full A, then I can just say apply the function to A. And up here, I had to reconstruct it, rewrap it up in optional because this just gives back a B. The F just gave back a B, and I need an optional B. Whereas this one does the wrapping for me. And we saw this same pattern with our map list and our, what was it called? Flat map. So our map function that we made, A, B, list A, list B, and flat map. A to list B, list A, list B. It's very, very similar pattern here. So Pete, what other books or resources would you recommend? What other resources have been helpful? And I'm also curious, I was reading something today that said there's a lot of Haskell stuff out there, and a lot of it is focused on more like understanding the language and type theory and all that stuff. And someone was saying it's kind of underrated or undervalued, like just learning by experience, building some app and shipping it is like maybe a better way, or a way that is not often used, like an approach that's not often used to learn Haskell. So maybe after this course, what I should do is just try to build like a really simple app and ship it, like even if it's just like a tic-tac-toe. Actually, this course might have like a tic-tac-toe at the very end. Oh, it's got some like a few things. Okay, don't get too distracted. Again. Okay, so bind optional should work. We don't need this F. We're not using it. So I'm going to test. Let me add source test optional test. And I'm going to test our map optional test. Okay, these tests passed. Let me test bind optional. Cool, so those pass. Okay, next we have double question mark. So it seems returns the possible value if it exists, otherwise the second argument. So it's just kind of like in JavaScript, this is like a nullish coalescing or something. So it's like if the left side is null or undefined, it uses this value, otherwise it uses this one. In this case, it's just if it's empty, use this. If it's full, just use it. Pete says, yeah, I think trying to write some little CLI program or something is a good exercise. Haskell programming from first principles kind of gets you to the point of being able to implement simple apps. Okay, so maybe it'd be good to do that and then do an app, or maybe I could do like a very small toy app and then move on to the first principles book. Does first principles have does it have a lot of exercises? I think that's the case. I think I heard someone talking about that. I would like to be able to stream, or at least have a record of my learning, if it'd be helpful for other people. But if it's like a copyrighted book, I wonder about the legality of that. I don't plan on like charging for this or doing ads, but I want to respect the authors and not like use their content. If that's not something I should do. But anyways, I'll have to think through that. Yes, plenty of exercises. Okay. Double question mark. So if it's empty, so we have the optional, the OA. Good show, by the way. And then we have the right value. So maybe I'll just call it OX, an optional X, and we have a Y. And if this is empty, we use the Y. So I'm just going to say empty Y. And if this is full X, then we don't care about the Y. We return the X. So this should be full 8 and empty. Yeah, there we go. Test. See. I don't know how to like see which tests there are. Maybe I can browse. Browse, source, test, optional. No. Maybe I go to optional test. Oh, okay, so maybe this is value or. Maybe that's how you read this value or. Yeah, okay. We got that one. This is going a lot faster than list, I think, because this module is actually supposed to be the first one you go through. Okay, try the first optional for a value. If it has a value, use it. Otherwise, second value. So this is similar. Okay, so full 8. Is it? Oh, it's just like, it's like an or, I guess. So if this is there, just use it. If it's not there, then try this one. And if none are there, then use this. Okay. So I think maybe I need to just iterate through all of the options here. There's probably like a fancier way to do that. I'm just gonna keep it simple and say, oh, I don't need to deconstruct this, right? Because if I basically I don't need the x, I need like x this because it just stays an optional. And then empty x. Is there a better way to do this? Like this feels very verbose to like iterate through. Maybe I'm supposed to use this operator. Yeah, can I just implement so do I just say maybe I call this x and y and then I just say x value or y? Doesn't like y. Can it construct the infinite type? Oh, because this returns an a. So do I just say full y? No, I say full result of whatever this is. Oops. So this function will unpack it. Oh, but I do need to. Huh. Maybe I need to say. You know what? I'm gonna just do the simple version and then come back. Start from a working station. So if it's empty, empty, return empty. If not, if this is x, then x. 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 Actually, I think this can cover. Maybe I'll leave it. No, because if they're both full, I want to use the first one. So if this one's full, I don't care about this one. So let's get that working and revisit. I think what you had is good. I don't think the value or function. Okay, let's. What is this one called? First full test. Okay, that works. It just feels like this should work. But this x, so the first argument to this is an optional, and this one is not. Yeah, I don't know. It maybe 3 lines, like these 3 tiny lines is not so bad, right? Maybe I'll stick with it. The first line that you have not covered by the second. I guess it is because if this is empty, I return this regardless of if it's empty or full. Like because if they're both empty, I return empty. And if this one's full, I return full. You're right. So I can just do this. Thank you. Good call. Good call. Yeah. I wonder if I could even just say like, no, I have to pattern match. Okay. So replace the full and empty constructors in an optional. I don't know why they wrap everything. Okay. So optional, it takes a function and then some value and then an optional. So what really helped me was Brian McKenna's stream where he goes through this course, and I'm kind of like stealing his idea, but uh, the reason I wanted to also do the stream is he did it like 2 or 3 years ago, and some of the exercises have changed, and he didn't go through all of them. So I'm hoping to go through all of them. Also, I'm a beginner, and he was like a Haskell pro, so I wonder if there's some benefit to having people at different skill levels. Anyways, that's my justification, mainly just because I think it's fun. I hope Brian doesn't mind that I am also doing this when he's got a video series out. But what Brian McKenna said is this function is kind of like the fold right for list. So, so fold right like takes a function, in this case, what do you call it? A function that takes two arguments. There's like a formal name for that. I forget. Takes a function. It takes like a starting value or a default value and then a list. And then because you have a function that gives a b and you have a starting b, you always have like a b to return. So this is like the function's like replacing cons and replacing nil. So it's like constructor replacement. For optional, it's a very similar structure. So it's like we have an f, we have in some x starting value, and then we have our, maybe I'll call this y, and then I don't really know what to name these things. So I'll call this like, maybe I'll just call it b OA for optional A. So throw in the good old typed hole. The to do should be a B. And I'm thinking just like map. Can I just use a map here? I might just be able to use a map here, but let's go through it just from scratch first. So yeah, if this is empty, then I can't use the function, but I have to return a b. And I have a b here, so I'll just do this, and then I don't care about the function. I'm not using it. But if empty is actually a full A, then by calling f on A, that gives me a B. That's what I need to return. In which case, I don't care about this starting value, I think, because yeah, replaces the full and empty constructors in an optional. So maybe like fold right is constructor replacement, just like you're replacing the nil constructor and the cons constructor. This is like replacing the full constructor and the empty constructor. I see. So maybe I should, when I'm using this in the future, I should think like, I don't know, full and empty. So like this is the function to use if it's full, and here's the default to use if it's empty, and then some optional x value, something like that. So, but if it is full, then I can use the function on it, so I don't care about b, in which case, done. Ink. Test optional test. Bam, there we go. Let's test. I think we can do the whole, yeah. there's this pattern used in the course where in order to run all the tests, excuse me, you do this test underscore and then the name of the module. So can I just use map optional here? That's going to return an optional though. But then maybe I could combine it with this. Yeah, so maybe I combine so I have F here. Map optional takes a function and an optional A. So this is going to return optional B, which might just be empty. So if the value I gave it is empty, then it just returns empty. Otherwise, it calls the function. So this could be function. So I could use this. So if it is empty, I just use this E value. Because map optional handles the instruction for us. That makes sense. Did I explain that properly? And if anyone wants to chime in, has any cool kind of cool nuggets of knowledge about this, or like, yeah, I'm very keen to hear those. So okay, let's retest optional. Test. Pass. Okay. That's pretty cool. Okay. That was short. I also turned off my default formatter because it was really bogging me down. So maybe I'll run the formatter. I don't know if that changed anything. Oh, I think it swapped the order of these for some reason. Sure. For HLint. Cool. So we're done with this. So what I think I will do is, which I forgot to do last time, is Tony Morris, the author of the course, he has his solutions posted here. So maybe I should go through. Nidico says, "Hey, how's it going? It's going pretty well. I'm doing pretty well. Basically, everything outside. I'm in Tennessee, and everything outside is covered with a layer of ice. Like that's not an exaggeration. Everything is covered with ice. It's crazy. I hope everyone out there is staying safe. So, especially like Texas, I hear is going through some crazy weather that they're not used to. So Tony Morris posts his solutions. So maybe I'll go through his solutions for list as well, even though I've already completed that. Okay. This way. Map optional. Okay, he did that the same way. Did this one the same way. Okay, so he defines this. He defined it like this because it's an infix operator. I don't know. That makes me uncomfortable. It feels weird to me. What do you all prefer? If you're defining an infix operator like this, do you put the start like and it takes two values? Do you put the first value on the left? Does this work? Let me make sure this works. Yeah, it works. I don't really like that. I think I'm just gonna leave it like this, unless you all insist that that's what pro Hasklers do. Then I suppose I'll need to learn to love it. Nidico says, "Wow, we got some heavy snow in the Netherlands as well. First time since 3 to 5 years. First time you've had snow in the Netherlands for 3 to 5 years? Or just like that amount of snow? I would guess the Netherlands gets snow more often than that, but prefer. Yeah, I think I prefer this, like wrapping it in parens for the definition. I mean, if I'm gonna use it, like I used it down here, like I'm gonna use it in fix when it makes sense. I guess I just like that these question marks all line up together. It feels readable to me. Um, maybe I should learn to like this style of doing it. Anyways, this is, I usually read it. Oh, Pete says I usually read it in fix, less parens. Nidico also like the parens. We haven't had any snow in years. Wow. The other one's getting snow for the first time. That's cool. In a long time. So it's just preference. This, which forget what he called this. First full test. Oh, he just checked the full case first. We're checking the empty case first. Fine. Optional. Okay, yeah, he did it. Our first solution was similar to this, and then we utilize this map function in this. Which honestly, this might maybe be better, just because it's so simple. Whereas, I don't know. I mean, whatever. I think it doesn't really. Okay, that was pretty simple. So we finished optional. Maybe I'll git add complete optional. What? Doesn't like that. That's weird. It doesn't like the exclamation point. Is that a bash thing? Choose single quotes. By the way, if anyone wants to see my solutions, for whatever reason, you can go to shoot. GitHub lowderdev. Yeah, I mean, I have my solutions. I'm going to be pushing to a branch stream. You can see that there. If you ever want to come back and see what we did. Okay, so let's go through his solutions to the list and see what differences there are and what I can learn. I missed things. Oh, also before I do this, because I accidentally did list before optional, there is a problem in here, seek optional, that I skipped because we hadn't done optional yet. So let's go through it now. I think I got started here and then I decided to wait. So we have a list of optionals. So if the list is empty, yeah, so this is a weird one. So we have a list of optionals, like full 1, full 10, empty. And we want to go to an optional list. So either empty or full, some list there. And it's going to check us with an infinite list. The course likes to do like that. So have any of you done this course before? I'm just curious. So if the list is empty, then it's empty, right? So yeah, seek option. Oh wait, no, an empty list would be full empty list. It only takes one argument. So full nil. Which I might not need this line. Otherwise, maybe I don't need to pattern match on the list here. So I have some list, and I think I just map over the list some function, and then yeah, maybe I'll fold right, and then cons L. And then at the reduction. So I just need to figure out. I think this cons is going to need to check the optional. If it's empty, then oh, the default shouldn't be nil because it needs to be an optional list A. So it needs to be full nil. That matches our type here. So let me load course list. Because says I've done Haskell programming from first principles like 5 years ago. Yeah. PF Murph, who said that the name Pete was fine. So Pete said that they also did that book. So maybe that's another sign that I should do that book. Like a good one. This cons takes an optional A and an optional list. Turns an optional list. So I think we just need to unpack the optional, and if it's empty, then we return empty. If it's a value like full 1, full 10, then we just start appending the values to the null. So we get our optional x, and our optional x is ox. Is the year of the ox. I had almost 0 programming experience, so I like this slow, steady walk through the concepts. Oh, cool. So, for the first principles book was your first, like, experience learning programming. You didn't do any programming before that. I did most of this stuff in my head as long as it was. Solidify the knowledge. That's cool. So it doesn't like this. Oh, I need to refresh. Okay, found the hole. So I have an optional A here. In fact, maybe I'll just call it OA and then OAs. So I need to check this value. And I think I can just use this value or thing. Well, maybe not. Yeah, I guess what I'm thinking through is I could check the optional value like this. But what am I going to do with it? So I have to give some default. But really what I need to do is if this is empty, I want to, if this is a full value. So maybe it would be better to say, start out with this and then maybe we can simplify it afterwards. So I'm going to say f is a function and then say like fold f over my x's. Can I do at a reduction this with the let in? I need to define this. Just say empty. Can I just remove these x's here and it still compile? Yeah, okay. You could use where instead of let in. Yeah, I I haven't developed an intuition for when my experience is when I use where the type when I use type holes, like the type information is not as good. Like, but using let in for whatever reason, or maybe that's only when it's like inside. Like if I define this function and on let in side, maybe that's why I'm thinking let in is helpful. Um, so sort of I tried Python, JS, Ruby, but programming never project where a friend did the programming in Haskell and I had to add to the code base. I learned super rudimentary parts. Clicked. That's awesome. Yeah, it seems like maybe practical use is like a good way to we were talking about that earlier. Maybe it's a good idea to do just like some practical project. So I'm thinking here, if this is empty, then return empty. Because if there's any empty in the list, so this first argument will be that the next element, the current iteration, like the current value of the list we're inspecting. If it's empty, if any of them are empty, want to bail and return empty. Which means we need to check, because like if this was empty, we get here, I think we still want to return empty in that case. So we only return a full list when all of the values were present. So then, so I guess what I'm saying is if this is empty, then we also don't care. Then we don't care what the value is. It's only when this is some full x and this is a non-empty list. But I actually need case. And here I append x to x's. Except x's is optional list. So I guess I need to do full x's. And then I need to return an optional. So I say full. Yeah, so if either the value of the list I'm looking at is empty or the list so far that we've accumulated is empty, return empty. But when value is full and the list is full, then we deconstruct those, append, and then reconstruct the null. Okay, let's try. Hey, always feels good when it compiles. Okay, so that works. This returns empty. If this were full 20 dead. Oh, I have an empty. I put another empty. Hey, full one. Yeah, and 20. It's weird to me that they don't show the case. Oh, I wasn't scrolled far enough. Yeah, this is the happy case. So let's do test. Optional. Test. Was there an add source test? Optional. Yay, it worked. Okay, so what can I do? Definitions and where are in scope in the entire function. Let definitions only in the in. Right. I prefer where if possible. Only use let when I need definition. Oh, okay. That makes sense. So just for the people who might watch this later on YouTube, like if we did something like this, we said let foo in bar, like then does that change? Let's say I said let foo into do. Let's just actually just see that. Oh, and I'll just say foo. Make it file, and then maybe I have to move it up here. Trying to understand the difference between. So in this case, there's to do, and then I see the relevant bindings. I see foo, and I see x and y, which can be helpful. But if I change this, if I take this out and I use like a where foo equals 1, does that matter? Let's see that. Yeah, I see the same. I can still see x and y here. I don't know why that. I feel like I've had experiences where using where didn't tell me something useful, but let in did. Maybe I'm making that up. You can replace the top two definitions with f underscore underscore. So let's change. We had bold right f. Let's try using where instead of let in. Test it again. It works. Okay. So I can change this to just underscore underscore. But oh, I just do this one first. I see. Yeah. Right. Yeah, because we check the case we're looking for first. Because if it's not this case, every other case, or both of these cases, then we can remove line. Good point. Reload. Okay, still pass. Cool. Should we inline this and like put that here? I think I'll just leave it because that feels like a lot. Well, yeah. Might be able to refactor F to apply optional A. Call. Oh yeah, because this is going to end up, yeah, being an apply kind of thing, which we haven't talked about yet. I think you're right. So let's look at it. Apply optional. Good catch. Helper functions are often called Go. I have seen that on like chat servers and stuff, like beginner Haskell. In the functional programming Discord, or was it Slack? I can't remember. I think it's Slack. There was like, I've seen people use Go a lot. Yeah, apply optional. So it takes an optional function and an optional value. Oh, maybe we have to use twice optional. I almost always make a helper function, accumulating functions and folds. Yeah. It's sometimes, unless it's really terse. So I think twice optional because we need two values, right? We have like the full value in the full list. And then this would just be append, I think. Let's try it. Twice optional. So instead of F, twice optional. So just to break this down, we have like an optional X and an optional X's. And twice optional, take some function. Oh, we didn't do this one either. This wasn't an exercise. It was already here. Apply optional, which does bind optional, which does map optional. So it's like building on everything. So yeah, so I guess what I'm thinking is twice optional takes this function, which in our case would just be append cons, and then it takes the optional x's and the optional x and the optional x's. And I know I don't need to do all that, but I just wanted to demonstrate. Hey, yeah, it does work. So then, yeah, so HLint is very helpful. But I mean, maybe I should explain it rather than just copying. So because it's at a reduction, so this is the left side of the equation, this is the right. So we just simplify. We don't need the lambda. This. So twice optional, I guess that's not a very helpful name in my opinion. But maybe it's more like maybe it's basically lift, right? Nidico says, have you ever seen F map A applied B? I have seen that. I have seen that only because I'm cheating a little bit because I started this course. I did a bunch of it, and basically I went through this course, and there's this I found this video series, Brian McKenna. Maybe I should have searched FP course. And yeah, he's got this series where he's going through the FP course. Oh, he actually did make it to JSON parser. I think he doesn't go through the whole thing. Maybe he eventually did get through the whole thing. No, so he did the parser, and he skipped some of them. So anyways, the reason I brought that up, I did this this course, I got to like past where Brian McKenna got, but I kept doing it. And I was like, well, wait, maybe I should. One, it's super. I was having a ton of fun doing it, and two, I thought, um, yeah, maybe I should do the whole course so that there's videos out there for somebody if they get stuck. And so, anyways, that's where I've seen the pattern you're talking about from this course, which is the yeah. So this is like a lift two, which we'll see in a bit. And yeah, it's like we're kind of making our own um, bind, right? That's what fmap apply. You can your own bind. I think I'm saying that right. Okay, cool. So we finished this optional. So now let's go through um, Toni Morris's functions. Um, I need to, you know what I need to do is like set up my, need to learn some Twitch skills. I can get, seeing now that like some people have followed me. I didn't notice. I should, yeah, I need it to flash on the screen so I can shout it out. A pro Twitch streamer. Okay. Infinity. So the fold right and fold left were already there for like helper function. Oh, interesting. So head aura, you can just do fold right const because we were pattern matching. But fold right will handle this null case for us, and we're just using const over the list. So let's see. Yeah, so the const gets this value, which becomes like the default. Yeah. Product. Yeah. Folding the multiply over 1. Sum is folding addition over 0. Length is, oh, interesting. He did const composed with +1, and we just did const +1. So our version just throws away the first value. Well, it throws, yeah. And then, interesting. Map. Yeah, so this is the same. You apply F to A and then append it. We just, you're a little bit fancier there. Aha, got one up on Toni Morris. I was probably just trying to keep it. Filter looks the same to me, except he's returning a function rather than an actual value. So we did append and then else this, but he said acons and ID. Yeah, I used P for predicate rather than F. More descriptive name. P. Flip fold right. So that, yeah, this is append. Folding append. But it flipped the values. Rams. Latin is the same. Latin. Flatten again. Same thing. I don't want to like re-explain these. Already talked about it. Okay, find. Oh, so he used filter. Did he need to do that though? So we used E. It's very similar to filter. Oh, this kind of cheating, right? So he filters, gets all the values that match, and if there are any, he just gets the head. Otherwise, empty. Whereas we actually went through the work of, like, I guess we kind of are re-implementing filter here, and maybe because it's lazy, there's no like extra work being done. Or would you have to use fold left? No, if you do fold, I don't know. If you implement find with fold left, since it's eager, would this test fail? Oh, indeed, because of laziness, the filter only goes up to the first value. So maybe this is better because just we're kind of re-implementing filter here. Where did filter go? Yeah, I mean, so we're kind of just doing this same thing, right? Back to I want to compare. Very similar. Yeah, so it's just we're doing full A instead of a. And it returns an optional instead of a. No, yeah, yeah. With fold left, would have to traverse the entire list. Yeah, because it wouldn't. Yeah, it wouldn't. Length. He also did this. This seems like length greater than 4. Seems like it might be a challenge to do this without doing the pattern matching. I guess you would just need to check the list of the length of the accumulator. And yeah, I don't know. There's plenty of other exercises to do. I don't want to create my own exercises. Reverse is, yeah, flip. So, and then produce, these were helper functions that weren't exercises. So, since Nidiko and Pete are seem to be Haskell experts, have you ever have my solution there? So last time, one of the viewers, Luminator, which I later found out was a friend from. I just didn't realize it was one of my friends. Um, a new friend I've made recently. He basically walked me through how to implement reverse with fold right, and it was a really interesting challenge. Maybe I won't. I was gonna maybe challenge you all to try it, but I think maybe it hasn't been that long. It's only been an hour. So I think maybe I'll take a stab at one of the next modules, but I'll quickly go over the fold right version. So the fold right version of reverse um, flip compose composed with append ID. So basically, the way it works is maybe this is not cool to you all, like, but this kind of blew my mind. um, so let's see. Where's like the finish of the final? I think it. Okay, so this will compile, I believe. Let's try it. I can add a reduce it. Test, reverse, test, failed. Reverse, reverse, then append is the same as append, then reverse. Oh, so maybe it's not quite the same. But I can demonstrate like reverse. Oh, I have to use custom thing. So that works, and reversing a reversed list. But it looks like there's some test here that failed. No. So let's see. Version. Okay, so maybe there's something different going on here. Oh, you know what? It might have been I had the A's in the wrong place. So I think maybe it was go here. Yeah. Yeah, okay. Okay, so what's happening here? If you think of it as constructor replacement, I'll start over. Fold right is like constructor replacement. So what do we replace the nil with? Well, we replace it with ID. And then what do we replace cons with? This is kind of not readable. So let's define this function pipe, which I think is in base Haskell. It's flip compose. So it composes left to right. Yeah, here. So then we replace cons with cons with flip compose after cons. So basically, if we replace this with F and then let me see. Now I'm having trouble explaining it. But basically, you're folding. Yeah, maybe this version is. So we have this function pipe is flip compose, and then F is a fold right over functions, which default value is ID. So this fold right yields a function. So it maps over this list, and it creates a function from each value. So the first function it creates is append one composed with append one compose, like compose right. And then it folds again and it turns the next element. So basically it just builds up a chain of functions that like, yeah, so one appended to two appended to ID. And then you apply that function to nil. So ID takes the nil and then appends all of the values to it. Really cool. Really cool. It took like an hour of him explaining it on Twitch chat for me to finally get it. Not only to like have it compile and work, but for me to understand. Maybe I should put a note. Fold right version of reverse clue walked me on stream. Emoji. Okay. Yeah, it's not like not exactly useful, but it was a really interesting challenge. Okay, so it looks like I just inlined the filter, and then we implemented optional, added the note, and then I removed the to-do. So list. Okay, what is the module? I might try to do, okay, Functor. I think the Functor module is not actually that long. Yeah, it's like 4 or 5 exercises. We'll see how far we can get. So, by the way, I have a question. I do not understand in GHCI the difference between add and load. So let me full screen. Add modules to the current target set. And then load modules and their dependents. And I've just messed around a lot trying those two, and it yields different results. Sometimes the functions I want are not in scope, and sometimes they are. And sometimes I think using load will sometimes remove previous modules that you've added. I don't know. There might be something weird going on with this GHCI file, because it looks like it's loading. It loads course and test loader and adds the test loader module. I don't know. Maybe I've read a little bit about it, the GHCI docs, but to be honest, they were not very helpful. Okay. Functor, go. I honestly never use those nowadays. I just start GHCI my project and that's about it. Hit R for refresh. Yeah, same. I guess like I just loaded Functor, right? If I try to do like test Functor, like it's not there. But test list is, I guess test list is, yeah, none of the tests are there. So then now I have to say add source test Functor test. And now like you'll see all these tests are there. So I guess maybe in your usual development setup, just all of the whole project is loaded into your target set, or and then all the functions are available. Like, do you ever try to use a function and it's in your GHCI and it's not in scope? Anyways, maybe it's just you load a certain, I don't know. I'll figure it out someday. Okay, so functor. This is a big scary word that I didn't understand until I did this course. I'm going to collapse these comments. It's on. I know that Nico and Pete already know what this is, but Nico says I mostly stack GHCI library package. Okay. Yeah. So maybe that's why, because this isn't set up. This wasn't set up to use stack. I ran this support script in here, copy tool files, which copied over the stack.yaml and whatnot, make it work with stack. But I don't think it's like optimized. It's not like it didn't start from like a stack new or stack init or whatever it is. Okay. Yeah, so I know you all probably, I mean, for sure know what this is. And I've done this module before, but I've not had to explain it out loud to anyone. So Hope you don't mind me explaining it out, trying to explain my own words. So all instances of the functor type class must satisfy laws in the window. These laws are not checked by the compiler. These laws are given as the law of identity, which I think I read this as for all x, id, and then we'll learn that this is pronounced fmap right here. So id fmapped x is, what is this sign? Is this like is equal to, is equivalent to? I don't know why it's like not a regular equal sign. id fmapped onto x is equivalent to x. So in other words, using fmap should not change x in any way when you're using id. And then the law of composition for all f, g, and x, I think that I'm reading that right. F composed with g, or f after g, f mapped to x. Actually, with this, I'm actually not sure what happens first in the equation. If I say, yeah, well, maybe I'll try that later. So f after g, yeah, maybe it's saying like f after g, f mapped to x is equivalent to f mapped to the result of g f mapped to x. So I'm trying to think, how do I explain this? F equals plus me, f is plus. Right, but this is, I don't know if it's not big enough, but this is not the, whoops. This is not the equal, like, symbol. It's like a squiggly equal. All right, it's really slow when I change the symbol. It's an old computer. This symbol, visually defined as approximately equal to, may refer to approximate equality isomorphism. So maybe it's using that rather than equals to say it's isomorphic, not exactly equal. But anyways, the value of x, like this should not change the value of x. It should not affect x. So yeah, if someone's watching this and this doesn't, like, isn't clear, it will become more clear. So fmap is, well, basically once we have like functor implemented a little bit, I'll try and demonstrate these laws, prove them, and then I want to try to come up with, just for my own benefit too, I want to try to come up with examples, counter examples, uh like implementing an fmap that breaks these laws. That might be a good exercise. Okay, so now we're introducing this class keyword. I have not talked about this on stream yet. So class is not like object-oriented class, and I'll just explain the way I'm thinking of it, and for those watching, please correct me if I say something incorrect. Class, this class keyword is not the same as an object-oriented class. Not at all the same. So an object orientation, like in Ruby or Java or whatever, you define a class which has methods, and then some instance of that class a class is like usually a grouping of data and behavior, and then there's inheritance. So you could make other classes that inherit from a class that now have those methods available to the instance. But this is saying this is a type class. So the way I'm thinking about it is more like an interface. So Functor is a type class where k is some data type, like list, and you can have an instance of Functor. So basically, an instance of the Functor type class is a data type where this function, pronounced fmap, exists and also follows these laws. However, the compiler does not check that it follows these laws. It checks that it exists. So you'll see, we say, I'm reading this line as, I'm defining a new instance of the functor type class. I'm saying exactly one is an instance of the functor type class, where the fmap function equals this implementation, which we haven't done yet. So I hope that was a decent explanation. I'm trying to use my own words. So let's go for it. And then once we implement this one, maybe we'll go back and check that the laws hold. Okay. So this is how it maps a function on the exactly one functor. So +1 fmap to exactly one 2. So if we just go back, this is like a toy class, toy data type that just wraps a value in constructor. It's not full. It's basically optional without empty. So it just kind of puts a value in this box called exactly one. So go to functor. So I'm gonna have an f here. I'm gonna have an exactly one a, and I need to return an exactly one b. Good. So I need to return exactly one b, and I have an f which takes an a, and I have an exactly one a. So I'm gonna need to get this a value. So I'm gonna unpack it, and I don't really have to do check multiple cases because exactly one only has one case. I'm just gonna say f, apply f to a, which will give me a b, and then I'm gonna wrap it with exactly one. Then code test functor function test add source test functor test. I don't know how to get at the test for this. Check functor test. Test. Doesn't look like there is a test for exactly one. They'll just persist. So let's try it out then. Okay, so now we start to see what this does. So +1 f mapped onto exactly one to a confusing name here. It basically just injects this function inside this data type. So we have an exactly one 2, and we inject this function inside the exactly one, and we get an exactly one. Whereas if we tried to do this with just regular function application, blows up because +1, you look at the type, sorry, I hit my mic. Type of +1 takes a number, takes an a, not an exactly one a, but this. So with fmap, can achieve that. So then let's test these laws. So we have the ID function. So if I do ID mapped to exactly 1, 5, that's exactly 1, 5. So that, yeah, that should equal exactly 5. I guess I have to wrap these. Wrap this or use, yeah, okay. Yeah, so that law seems to hold. The law of composition. So the law of composition says if I compose I'm just going to keep it simple. So I'm going to say +2 and +3. If I compose those and then fmap that to exactly 1, 5. So this should say like add 3 and then add 2 and then inject that into here. So we should get 10. And maybe I should say multiply by 2 just to demonstrate. So add 3 first because composition is left hand like F after G. Whoops. So it'll be 8 and then 8 times 2. That should be the same as use a lot of parens here. Sorry, I know you all said you don't like parens. This should be isomorphic to or equivalent to plus or times 2 f mapped to the result of +3 f mapped exactly 1. Wow, that is a mouthful. And of course I messed up on the parens. So I think we're starting to see the value of fmap as well because this is like insanely hard to read. So I'm gonna put this here for the benefit posterity. Oh, law of identity. Law of I think I can eliminate friends here. They all of them for a moment. So exactly 1. We're saying do this first. So fmap +3 onto exactly 1, 5. And then multiply that times. And that should be the same as side here. So composing these first and then f mapping the composed function. Same as f mapping them one after another. That is true. Cool. So we just demonstrated that these laws hold for exactly 1. And I think that also helps give a motivation for why it's so useful. I mean, it's basically like map on list, right? So that's the other motivation. Is like once you start using map, you're like, man, this is really nice. This is a lot better than doing for loops. So it's kind of like the same thing, right? So yeah, all the parentheses. So let's go to the next one. So let's let's declare list is an instance of the functor type class. We take a function, we have our x's, and we need to return list b. So we just map f over x's. I mean, we implemented the map function in map test list test, and then we can edit reduce this to x's sides, and then we can do this. So for list, fmap is map, the same thing. So it's equivalent to say map type times 2 over my custom list, quite tedious. Why do I not have map? Right, I don't have loaded in. This is the kind of thing I was trying to say earlier. Like, yeah, it's like map wasn't in scope. I had to add the list module back. So that should be the same as saying fmap, and I'll wrap it in parens. So yeah, so now I need to see. Now I have to add back. It's like adding the list module, like remove the functor stuff from scope. Okay, so wait, is map gone now? Let's test that. Oh, okay. So these are the same, and typically you wouldn't put parens around it, right? Okay, like that. Fmap. Cool. Okay, so optional is also a functor instance of the functor type class. And so now we're starting to get an intuition for what a functor looks like or feels like. It's common to use these. Nidico says can also be more. So Pete says it can be more efficient to have composed f and g f map only once. Why is that more efficient? Is you mean for? Oh, so maybe if you had like a big tree data type and you wanted to multiply every node in the tree by 2, you would like fmap multiply, you'd fmap times 2 onto the thing. And then if you wanted to go back and, okay, now add 3 to it, then you'd have to go through the whole tree again. Whereas you could just compose the +3 and the times 2. Yeah. Okay. Wow, I did not realize that. But that makes perfect sense. I guess because I've only used fmap for very simple data types. But even list, you're traversing the entire list. But yeah, I guess I haven't very long lists. Unico says it was in scope, just qualified would have worked. Yeah, I think P is like the prelude, the qualified import of prelude. So it wasn't our implementation of it. This thing. Yeah, fmap. So it's pulling in the prelude's fmap. But we're meant to use that. Okay, so might be rewrite rules or something like that. Yeah, so maybe if you're f mapping a bunch of times, the GHC is smart enough to like compose them. That would be cool. Optional. optional. So let's take an F. Let's take a O of A. And let's do this. But I think we can use a little bit of we can work a little bit smarter here and see. Okay, for list map, F map was just map. And if we go back to um, optional, we have a map optional. One would think that you could just use map optional, which basically just constructs it and applies the value if it's not empty. So map optional, test option, yes, test for that. That's still empty. And that works. I don't think I need to demonstrate these laws for list. I mean, it wouldn't be that hard though. Just say one name is L. That's true. So yeah, well, so just gonna replace exactly. Just gonna replace exactly one with this list. I mean, yeah, the exactly one 5 here. And then I'm gonna run this. Oh, that's true, and I'm satisfied with that. I don't want. I'm not gonna like dive in. You know, I think it's clear enough. That's makes sense. Optional. Yeah, it's this. Optional is basically like list except a max length of 1. Okay, so this one, this is where I might. I think I could benefit a lot from uh some input from the chat. So I'm gonna format the document. See if HLint stop bothering me. HLint doesn't like the prefix version of the arrow. So again, I'm just leaning on what I gleaned from Brian McKenna's videos that this reader T functor. So this arrow is basically a function, even though we're just used to seeing it in the type signatures. So I don't know how, maybe info. Okay. Huh. So this arrow is a data type. That's kind of mind blowing. The data type. How is it constructed though? So weird. Is there some magic happening here because it's like the arrow? Maybe one can. I might just have to regurgitate what I've heard, which is basically this arrow is a function that takes an a that is some type and a b. I guess it's just like it itself is a function that takes some input and returns some input. I don't know really. Not sure how to read those type Q, type R thing. Yeah, so maybe this is like some Haskell because you're starting to hit the bedrock of the language. So I think this is just trying to tell us that functions are functors, which should be the case, which basically means you can f map over a function. Let's break it down. Take an f and some here a, then to do should be like this t, so it should be like a reader b. What do I have in scope? I have this RA, which is like a TA, and I have an A. So RA, this thing is a function, it's not a value, as we see the arrow here. So I guess I can compose RA, because the A lines up, I can basically say like RA is A, F, A, B, then RA composed with F should be T, A, right? So because they have this A, this should line up, which gives me T to A to B is kind of the same as this T to B, which is what we need. Let's see if this works. I think we end up just putting compose in here. That works. Compile. Good match type A with T. No data constructor. It would be T, right? It might start the left-hand side of that as a lambda. Oh. So this. Supposing I had a T, how would I get a B? So then I would need to apply T to this function, right? No, F. I have this backwards, right? So it should be F composed with RA. Yeah. The test reader. Have a reader function test. test. Okay, that passes. So basically a function, I'm gonna see what HLint wants me to do here. So I think it's just saying instead of infix or prefix, just do the fix. Okay, so it's saying given a function from A to B and a reader T, or if a function from T to A, return a T to B. And this actually makes more sense to me because it's like I have this AB and a TA. How do I get a TB? Well, you compose them. And because this is the last, like I think if I format this, it's going to take the parens away. Let's see, format document. No, it doesn't. But I think I can just take these parens away and just say, like I have these two functions, then given a T, return a B. Which is kind of like what we're doing here. We're taking a T and we're passing it through this function. So then if we unwrap all of this, we should just be able to say, actually, is that what HLint is saying? Redundant bracket. Yeah, so I can just here see if that compiles. It does. Then I can do some add a reduction here. It's like I can basically just say if I wrote this infix or prefix, sorry, it would look like this. In which case these. Bam. That works. So the fmap functor to fmap over a function, compose them, I guess is what it's saying. Cool. That's so. I just have to take a moment and say, like, that is so satisfying. Haskell. I mean, I come from dynamic languages like Ruby and JavaScript, and so it took a lot of like banging my head against this. If it feels like I'm getting through this really quickly to beginners out there, it's like I've already worked through some of these, and it took a long time to wrap my head around this. I was not used to, you know, strictly typed languages, especially algebraic data types. But it's so satisfying to me that I can get this type information and I can just pull it, put the holes in and like see what needs to go there. And then after I get something working, I can just kind of reduce it down to its essence. And then you just arrive at this. It's like, wow, that's really cool. I think some people's reaction to this is like, okay, great. How does this help me? How is this useful? And I think that's kind of a hard question to answer, but the best answer I have is at like, what is this, the 20th module? We've already done, 3. Write your own JSON parser. So I don't know about you, but I've never done a JavaScript or a Ruby course or an Elixir course where like towards the end of the course you write your own JSON parser. That is pretty amazing to me. So it might not feel like this is very like useful. It feels esoteric, but what you're doing is, I guess you're the way I want to say it is like you're arming yourself with these super powerful abstractions, which are so incredibly expressive that somewhere down the line you can write your own JSON parser in like 100 200 lines of code. which I just find that really exhilarating, which made me want to do this stream and made me want to maybe do a Haskell thing from a beginner perspective. As a beginner myself, it was really hard to find Haskell resources that felt like friendly, safe. So I I don't know that I'm the best person to fill those shoes, but I wanted to at least try. So, um, anyways, that's my little diatribe. I think this is really cool. I think it's really amazing um, to like build up these functions and then just be able to reduce it down to something so expressive. Anyways, going on, continuing on. I don't know if I have the gall in me to try to demonstrate that the law of ID in composition holds for the compose function itself. That feels so meta. Should we try? Oof. Let's see. So I have to like ID f mapped over some function. What happens if you f map? How do I build a reader T? I give the arrow a single argument. Can I even do that? I don't know if I can even do that. You should watch. Nathaniel Bumpo says you should watch some Haskell talks from Edward Kmet. That I'm going to open a browser tab right now so that I don't forget. Edward Kmet. Phone address background information. Maybe I should say Edward Kmet Haskell. That might be a good video. Okay. Cool. Thank you, Nathaniel. I will check this out for sure. Why do you recommend just because his talks are very approachable and friendly to beginners? I'm excited to What about this reader? Is it even going to be possible to demonstrate this with I don't know how to create my own reader. I know later we do like a reader mode ad or like state T. His talks aren't very approachable and friendly. Talks are very deep. Oh, okay. That's cool too. Yeah, I think I'm just gonna have to pass on this because I don't know how to demonstrate that the laws hold for compose. Maybe is this saying what happens if I this x equals ID f mapped ID? Oh shoot. Does that work? So x takes a beat. So x is just ID then? Whoa. Then maybe I can do this. Where did I do this? Here. So ID f mapped with ID equal to ID. I don't really understand how that works. That seems wild to me. How does that not work? You can't compare functions to each other. So maybe I can say something like ID fmap to ID applied to 1 the same as ID applied to 1. Can't compare functions for equality, but you can probably just reduce both sides. I don't know how to reduce this though. Oh, so fmap, I mean, we just said compose. The way to implement fmap for functions compose. So we're just saying doing ID after ID is the same as maybe that's the better way to say it. What about composition? Is that, I mean, if we're just going to do that again, you do like a -1 here. Say, I type. So doing this whole thing applied to 1 should be this applied to 1. Yeah, that's kind of nuts. I don't know if that's I probably have to like add. Yeah. ID fmap to f is equal f for all f. Oh, you're right. So ID fmap to f. You're right. So let's say f is equal to +1. So then ID fmap f applied to 1. That's the same as f applied to 1. So then ID composed, yeah. So then maybe we can simplify this and just say f composed with f map to h should be the same. F map to g h. So f is +1 times h is -1. That's the like this, I guess. So then f after g, f map with h. All of this applied to say like 5. So what would that do? That would -1, that's 4. Then times 2 is 8 +1. That should be the same. This. Which of course it is, because for functions, f map is just composed. So we're just saying f composed with g composed with h is the same as f composed with g. Okay, I'm really glad that I tried to do this, that I decided to try to demonstrate this because now I'm getting I feel like I just got some insight into what's happening, like why a function is a functor. I guess I guess what I guess where my intuition is breaking is seeing this f f map g. Seeing the compose is obvious, or it's become obvious to me, or it's become like, oh, I can understand that. But I guess I've just thought of fmap as like inject into. So I've been thinking of f as like inject some function into a data type, but I'm not. But when g is a function, like how do you unwrap a function? You can't really unwrap a function. So I guess we're kind of unwrapping this function. Oh, is this like, so I'm thinking about it in terms of like wrapping and injecting. So in this, we had a function and we had a data type, and we're kind of injecting the function into the data type. If I try to think of it that way, this is a function and I'm trying to inject it into this. Injecting is like, because it's actually contravariant, yeah, arrow T breaks the intuition of functors as containers, if that's what you're used. Yeah, it totally does. Is that because this is, no, because there is something, there is a, like, later there'll be a functor. Contravariant. Maybe that's good. Maybe this is good enough for now, and then maybe we'll re-explore this contravariant. Yeah. Okay. Yeah. I think I get it now. I think this is helpful. Um, you can't really think of fmap as inject. I mean, most of the time you can. But then if I'm not allowed to think of it as inject, it's just like, I don't know how to have a different kind of intuition then. The inject intuition is so useful to I don't know what to replace it with. So maybe I'll just keep it and just try to remember that if it's a function, then like composition. Oh. Okay. I'm happy to hear if there's a better way to have an, maybe the way you just build an intuition is just functors a lot. Anonymous maps a constant value onto a function. This is like fmap but with left side. So I don't think we've talked about this fat arrow, but it's basically a type constraint. So it's saying this function anonymous map, I think is how we should pronounce it, anonymous map, takes an A and a KB and returns a KA, where K is a functor. So this is saying, just like we see like F, the function A to A, where A is some number, like this kind of thing, type constraint. So just instead of saying K, this B, so it's like if this is this could be an optional, or it could be list, or it could be anything that's an instance of the functor type class. So I have an A and a KB. And I need to return a KA. So this is where we start to get into like parametricity, I guess, where we know so little about what these things are. We just we're just using their structure to figure out what to do. So it's like I have this KB. I don't know what it is. Like if I knew if it was a number, then I might try to think about doing some arithmetic operation. But since it's a KB, all I know to do is fmap. So but it's in this case it's maps a constant value on a functor. So I guess I would just say take like just really write that out. Constant value, const a. I'm going to map that onto a functor, AB. So const a is a function. So const takes two values. So I can partially apply it to something, and then it takes an argument. So I can, maybe it's wrong to say this, but I can inject this function into the functor. So if I inject const a into an optional, it's basically like erasing the optional that was there with this value, because it's going to go inside this. Let's say this was optional, like optional 1 and a is 2, then it's going to unwrap the optional, say const 2 1, turn 2, and then get wrapped back up, so it'll just be full 2. Save my file. Load. I am curious though, is there a better intuition to have for fmap, or is it just something you have to put in the time and use functors a lot, and then you build it? Test a non-map test. That passes. So let's. So if I have 7, so this operator, a non-map, takes 2 arguments, and we're doing it in infix here. So it takes a 7 and a list, and then it's going to const with that given value, in this case 7. It's going to say run this function on 1, and then on the next one, and on the next one, it just yields 7 each time. And because fmap is implemented for each data type, this would be different depending on what's on the right side of this list. So for the case of list, it's map. So it's like we're saying map const 7 over this list. But if it was optional, map optional basically looks through, deconstructs. So let's try it and say, let's say it was optional, full 1. It becomes full 7. Empty, I think it just stays empty. Yeah. Just like if it was an empty list, say, I don't know how to demonstrate it with the. Oh, would this be like be const a composed with, let's say I have a functor that's like +1. Then I say +7. And then do this anon map on f. What is that going to do? So I have to assign it to G because there's no instance of show for. So then G applied to like 1 is a new function. What is the type of, oh, Type of G is that. The type of H is that. So what does H do? Ah, so H just adds 7. If I do H1, we get 8. Even though, yeah, so it ignores this function on the left, on the right. If it was using it, then it would be 9. Interesting. So Pete says, when I guess is the answer to my question. So I just think of the types. Drug, any of the functiony functor, like reader, state, or parser, you probably have a rough time if you try to think of them as. Yeah, fair enough. I think I'll just have to. I think it's just as I use them. Or use. A void. We test this. Void takes a k and returns k unit. So we haven't talked about this value, but this is a special value. You'll see it's pronounced unit. Unit has the type of unit. And so with the type like int, there's infinitely many values that inherit the type int. And with bool, so bool, there's only 2 types that inherit the type, the 2 values that inherit the type bool, false and true. With unit, there's only 1, and it's unit. So it's like ID or const, or has that kind of flavor to it. For integer, there's infinitely many. Int is bound, so it's very large. Okay, thanks. So int is int like 32 or 64 bit? How, like, what is it bound by? An integer is integer just like unbounded, so it's like gonna figure it out under the hood. I forget, to be honest. That's okay. I'm sure it's very Googleable. Feeling lazy. Okay, so void should take a functor and return a functor of unit. It's like if we had an like a full 1, it should return a full unit. So my KA here. I think I just do const unit a non-mapped over KA? That feels right to me. We just implemented something that ignores whatever's inside. So we just did this example like 7, a non-mapped with this list. So if like we just did unit, that seems like it would make sense. So why is it complaining? Couldn't match type, expected type K unit. Let's just refresh here. Couldn't match type B0 unit with unit. Expected type K of unit, and actual type was K of 0 to unit. So, okay, so I'm returning a function, a functor of a function. I just need to return the value itself. How do I do that? How do I construct a no, maybe it's is it like not work? Oh, maybe it's not a non-map. Maybe it's regular functor. Oh yeah, because that's what I did here. Okay, I messed it up. I just need to do this. So this is how I implemented a non-map, is using const and fmap. So I could either do const at fmap ka, or I could just use this, a non-map, and say unit a non-map ka. I think that'll get it. The test void test. That works. Void plus 10, 5. So literally, this is testing it with list, turns it all into units, turns it optional into, if it's empty. Oh, if it's empty, it stays empty. It doesn't get changed to. So I imagine that void on nil just, well, yeah. And then for reader, or for function, turns unit. Interesting. Cool. Cool. So we finished Functor. So let's I think what I'll do is compare Tony Morris's actions, and then I'm going to call it a night. Quick question: what is, since some of you have been interested enough to hang with me for like more than an hour, nearly 2 hours, which I super appreciate. I really appreciate it. Is Monday night a good night to hang, or what's a good night to? I'm trying to figure out what schedule to make. Obviously, there's no pressure to like come every time or whatever. I'd really be interested in like sometime. I've already reached out to some people. I think it would be really cool to do pair programming. So if someone wanted to make a little app in Haskell, and pair on it, that'd be really fun. So if you're interested in doing that, just reach out to me. Probably the best place would be Twitter, at lowderdev. I don't think you can message on Twitch, or you can find me on GitHub, I suppose. Okay, let's see what Tony Morse did for the functor. Exactly F, exactly one, same thing. List. Oh, interesting. He did it with fold right. And this is how he implemented map. So right instead of map. Map optional. So he used this optional function, which is pretty much like the fold right for optional. It's very similar. So fold right takes a function and like a replacement for cons and a replacement for nil, the two constructors, constructor replacement. And optional, this function, lowercase o, takes a replacement for the full constructor and a replacement for the empty constructor. So it's very similar to this. And I believe, how is map optional? Oh yeah, we just did the pattern matching, whereas this lowercase o has the pattern matching built into it by using. Oh, so it uses map optional under the hood. So, yeah, so it's the same. same thing as nav optional. So reader T. Okay, so he just showed that it's a lambda where it's f applied to the result of applied to x, which is the same as f composed with g. Non-map. This is clever. So you can just do f map composed with const. Really neat. And you can add or reduce the arguments. Const thing. Void. Huh. Oh yeah. Oh no, okay, I see. Put it in prefix. So by putting this in prefix notation, that would be like saying this, and then that means you had to reduce this right hand argument. Yeah, I like looking at comparing my solutions, the given solution, because I learned tricks like that. Test. Bam. Pass. Go. Here. Boom. So yeah, if you're interested in following along or you want to see these solutions, then the window. Tab. Lowderdev. FP. Yeah, I have a branch called stream. So if you wanted to follow along with those for any reason, find them here. Cool. Well, I think that's going to be it for me. I will probably do another stream this week. See what will be the next module? Applicative, applicative, and monad. You're getting into monad like right away. I did a lot of reading. Did a lot of read so many blog posts about trying to explain what monad is, and then I did this course. I was like, oh, I get it. So, pretty awesome. Also, this website, which I should point out, I can't remember what it's called. Typopedia, Typeclassopedia. No, it's not this one. Typeclassopedia. On DuckDuckGo. Typeclassopedia. I was not expecting this to be super helpful, to be honest. I was expecting it to be really dense, but it actually was really readable. Have you ever had any of the following thoughts? What the heck is a monad? How is it different from monad? Yeah, it was really helpful. Surprisingly readable. And there is there's a quote in here. I won't bore you by trying to find it, but basically it said it's best not to try to understand these through analogy, but just to understand them through their simply just through their definitions. So don't try to like figure out some fancy way to. In fact, it might be in this paragraph. Um, the second key, getting deep, back by example, also important. Yeah. So it's basically just saying like, um, it's best to just develop the intuition by understanding their definition and the laws. It's a monad or a functor is just their laws and nothing else, nothing less, nothing more. So if that was not helpful, just pretend that anything. Okay, that's gonna be it for me. Thanks so much for watching. Really appreciate it. If you'd like to follow along, I would appreciate a follow. Um, and you can also follow me um, at lowderdev on Twitter, and I'm going to be posting these videos onto uh, YouTube, so you can also see. Brian McKenna. Yeah, if you search lowderdev on, you'll find it. That'll be it. Thanks, Pete. Cheers. Appreciate your help. Catch you next time.